In this video, we will take a brief look at the working of our 3-in-1 integrated traffic driving networking simulator. Driving is a complex task that can be analyzed simultaneously from multiple research perspectives. Often, an experiment proposed in one research domain, such as transportation, can have consequences that can be studied in others, such as human factors and computer networking. In addition to creating a very realistic and high-fidelity simulation environment, our simulator is also capable of studying its effects in multiple domains in parallel. Let us take a look at the various components of the integrated simulator. The driving simulator consists of a 1999 Ford Contour vehicle cabin mounted on top of a 6 degree of freedom motion platform by Moog. One of our team members will now demonstrate its operation from the point of view of a test subject. We can see the vehicle cabin moving in response to his driving maneuvers. Additionally, the driver can also observe the RPM and speed dials moving and hear the engine rev as he steps on the gas. Our driver is currently driving from the University at Buffalo's South Campus in Buffalo, New York, to the North Campus, which is in Amherst, New York. As he drives along the highway, he can observe realistic landmarks all along the way, including buildings, traffic, and road signs. The background traffic that he sees around is created dynamically and controlled by the traffic simulator. It responds to his driving as he interacts with it through the driving simulator. Note the CTS messages are being generated by all the vehicles in the simulator, including the driver's vehicle, and exchanged over the wireless channel. We will discuss this in a moment. Let us first now look at how this traffic is generated and controlled. Here, we can see the traffic simulator PARAMICS communicating and running the scenario during a test drive. The different maneuvers from the driving simulator are being captured in real time and sent to PARAMICS, which can then mimic these motions in the scenario and override the driving simulator. We used NS2 for the traffic simulation in our integrated simulator. We enhanced an existing interface called TraCI to achieve this. Further details about TraCI can be found in the description of the video. At each time step, NS2 receives the coordinates of vehicles in a circular area around the subject vehicle. We have simulated the heartbeat and hard braking warnings on each of these vehicles and are exchanging the corresponding messages between them using the wireless channel. The heartbeat application sends out regular reports of the vehicle's speed, position, and other information to its neighboring vehicles. The hard braking warning sends out a message to the neighbors when the vehicle decelerates more than a certain threshold. The results of the simulations are constantly being reported to PARAMICS, which then takes the relevant actions on these vehicles. In our experiment, vehicles that send out hard braking warnings turn red, and those that receive it turn blue. Here we can see that one of the vehicles at the intersection has sent out a warning message and turned red. This message is in turn received by the blue vehicles. We can also see that the vehicles return to their default colors within a few moments of sending and receiving messages. Note that this specific vehicle is shown in purple throughout the simulation. The other vehicles in the scenario are reacting to these actions using the PARAMICS lane changing and car following models.